So this pre-lab is very important because that introduction might not be very clear to you of what you just read. Okay, so we're going to go through, and I have just a short little slide presentation to talk about the lab testing for iron 2 and iron 3. Now, we just said that we just talked about the other day different cations that you needed to use the stock system of nomenclature for, because they could have formed two different ions. In this case, we have the iron 2 plus and the iron 3 plus. And we are going to identify which chemical, which ion is present. You're going to see tomorrow that when you come up and you get a vial, you get one of the dropper bottles, that it's just going to say iron chloride. Now, if you would write that on a piece of paper, that would be wrong, because we know iron is multivalent. We know that iron takes more than one charge. So you have to tell which iron you're dealing with. Well, how do we figure that out? We do tests to determine the iron that is present. The first test is here. Okay, yes, I would write this down if I were you. Okay, I would write this down. Now, what you're looking at here, folks, is we're going to be dealing with the ferrocyanide ion, which is Fe parentheses Cn parentheses 6 minus 4. So right here is the ferrocyanide. Likewise, this is the ferric cyanide. Okay, so the ferricyanide right here, the I and the O are the only difference. However, the ferro is a 2 plus, the ferri is a 3 plus. So we have the two different cations of iron involved in this complex polyatomic ion here. So that is the difference between those two. One is 2 plus, one is 3 plus. When either of these complex ions combine with an iron in a different oxidation state, a deep blue precipitate forms. So this is telling me, okay, this is telling me when I combine these things, when I combine two different chemicals, and if I know one of them, and then it turns a deep blue color, it tells me certain things. So when either of these complex ions combine with iron in a different oxidation state, this deep blue precipitate forms. Now, one thing we need to talk about is a precipitate. Okay? A precipitate. What we are going to see is when we combine these two liquids, we have a solid that is formed. That solid is called a precipitate. So I combine two liquids, a solid forms. The precipitate sometimes can give you certain colors. In this case, the precipitate formed is a deep blue color. So what does this mean? If I have a deep blue precipitate formed when I add the ferrocyanide. Okay? When I have a deep blue precipitate formed when I add the ferrocyanide, in which iron was the ferrocyanide? +2, right? So if I add ferrocyanide, if I add the +2 and a deep blue precipitate forms, it tells me that the iron present must be iron 3. So if I have a substance in there that is just iron, I add a drop of this ferrocyanide and it turns a deep blue, I know that that iron was iron 3. What if it doesn't turn a deep blue? Okay, what if it doesn't turn a deep blue? Does it tell me anything? Okay, if it doesn't turn a deep blue, it tells me only one thing. It's not iron 3. Does it confirm that that's iron 2? No. It might not even be iron. Okay? But if I add that and it turns a deep blue, it confirms that I have iron 3. Similarly, if I have a deep blue precipitate that is formed on the addition of ferric cyanide. Ferric cyanide, and remember, ferric cyanide was the iron 3 plus. So what does that tell me? When I added the ferric cyanide, it turned deep blue. Tells me what? Tells me what? If I added the Fe, or the ferric cyanide, which is 3 plus, turns a deep blue, tells me that the other state is there. What's the other state? Iron 2. Okay? Iron 2. So if I add into my little well plate, turns deep blue, and I added ferric cyanide, I know that that iron 2 was present. If it doesn't turn deep blue, I know that iron 2 was not present. So is it very important in this lab to read labels? Yes, because there's only one letter difference in these two compounds. So it's important to read your labels. Now the confirmation test. The confirmation test is using the thiocyanate ion, which is SCN-1. The confirmation test is the thiocyanate ion. It confirms the presence of iron 3 ions. How does it do so? Okay, that's blood red. I put that color in there because that looks to me like a blood red color. So, in the presence of iron 3 ions, the thiocyanate ion will cause the solution to turn blood red in color. So, if you think that you have iron 3, let's confirm it. Let's confirm it. If you add thiocyanate to it, it should turn a blood red color. Once again, if you add thiocyanate to a substance and it doesn't turn bright red, what does that tell you? It is not iron 3, because if it were, it would turn blood red. All right? So, just because it doesn't turn blood red doesn't tell you it's iron 2. Okay? If I put water in there and add a drop of it, it didn't turn blood red, did it? No. But does that mean it's iron 2? No. It's water. It doesn't even have iron in it. So, if it doesn't turn blood red, you know you don't have iron 3. If it does, you do have iron 3. Now, other thing I guess I want to talk about beforehand. Open your lab to the data table. Okay? I want you to put a little note to yourself. Okay? I want you to put a note to yourself somewhere by this data table that says that this data table is not set up compliant with the procedure. Okay? This data table is not set up based on the lab procedure. So just because you put drops in certain places does not mean that it matches the data table. You have to read the data table. A lot of the people want to just follow across the different wells and say, well, this is the top left well, so it's got to be iron 2 and the ferrocyanide. That's not necessarily the case. These columns do not match your lab procedure. A lot of people throughout the years they miss these and they get problems wrong because they write their results in the wrong spots because they don't match. Okay? So I want that to be perfectly clear that the data table does not match the procedure. Okay?